All right, so let's look at question. The child puts a backpack and then the seesaw now balances. Calculate the mass of the backpack. So we are going to say that the anti-clockwise moment, anti-clockwise moment is equal to clockwise moment. So when the boy shifted, so we have 900 Newton times 0.85 meter. And then this boy put a bag on his back. So we have 450 plus W Newton times 1.6 meter. So if we work out this is 720 plus 1.6 W. And then this will now be 765. So let's solve. So 1.6 W is equal to 765 minus 720. So 1.6 W is equal to 45. W is equal to 45 divided by 1.6. That will give 28.125 Newton. But mind you, the mass of the bag is equal to W over G. So which is equal to 28.125 Newton all over 9.8 Newton per kg. So that will give M equals to 2.87 kg. So it's approximately 2.9 kg. So the B part of the question, the concrete floor under the seesaw is replaced with a rubber floor. Then a child falls from the seesaw and experiences an impulse when they hit the floor. Define impulse. So impulse is the product of force and the time for which the force acts. So impulse is equal to delta F times T, and the same thing as M multiplied by delta V. Explain how the rubber floor reduced injury on the boy. Use idea about impulse, force, momentum, and time for which the. So, for example, we know that the one thing you should know, when the boy fall from the seesaw, the change in momentum, which is the impulse, is the same on both floor. Okay, but the elasticity of the rubber floor increases the time of impact for a boy who falls on it. So what is the implication of this? Who falls on it and reduces the force of impact and and injury. So we know that F is equal to impulse over delta T. So when T increases, then F reduces. So that is the question. So let's go to question 5. Question 4 rather. Now question 4, figure 4.1 show a stainless saucer pan being heated on electric cooker. The saucer pan contains water, so this is what they're talking about here. And then state what happened to the water particle as the water temperature increases. What happened to the water particle? The particle moves faster and the average kinetic energy of the particle increases. So particle move faster and the average kinetic energy increases. Now the saucer pan contains 250 cm cube of water. The specific capacity of water is 420. The density of water is 1000. Show that the mass of water in the saucer is 0.25 kg. So first of all, we know that the mass is equal to density multiplied by volume. So for us to do that, we can now calculate what is the density. The density is 1000 kilogram per meter cube. So times this water, yes, which is what, 250 cm cube. So we convert the cm cube to to meter cube. So that will be times 1 meter over 100. 100 cm make 1 meter, so times 3. So if we do that, that will give us 0.25 kg. Now calculate the energy required to increase the temperature of the water from this. So let's find the temperature rise. Temperature rise is equal to 65 degrees Celsius, take away 20 degrees Celsius, which will give me 45 degrees Celsius. And then the energy, heat absorbed by water, is equal to the mass times specific capacity multiplied by temperature rise. So which is equal to 0.25 kg times 4,200 joule per kilogram per degree Celsius, then times 45 degrees Celsius. So if we multiply that, it's going to give you 47,250 joule. So it's approximately 47,000 joule. That is two significant figure. The heater supply enough power to heat the water in 30 seconds. That is assuming we can heat the water without any container. It will take 39 seconds. But a student measured the time taken to heat the water to be 100 and suggests why the actual time taken to heat the water is longer, because the water is heated in a container that is a conductor of heat. So the container is going to absorb part of the heat supply in heating the water. So the thermal energy is transferred. Thermal energy is transferred to the pan and the environment. It's transferred to the pan and environment during the heating. So it took a longer time. Okay. Then question C. The specific capacity of the stainless steel or steel is 500 joule. Y dot of aluminium is 890. Explain how using aluminum saucer will affect the time taken to heat the water. Now, if you look at it, the specific capacity, this one is the specific capacity of steel, and then this is the specific capacity of aluminum. So the specific capacity of aluminum is the difference is 390 joule per kilogram per degree Celsius. Okay, so you see that the aluminium have a higher specific capacity. Okay, now let me just explain what we mean by specific heat capacity. Specific capacity is the amount of heat energy, thermal energy required to raise the temperature of 1 kg of a substance, 1 kg of a substance by 1 degree Celsius. So the amount of heat needed to raise the temperature of 1 kg of a substance is the specific capacity. That means aluminium, the specific capacity is 890. That means 1 kg of aluminium will require 890 joules of thermal energy for the temperature to rise by 1 degree Celsius. So the reason why it's going to take, so heating the aluminium is going to take aluminium pan. So an aluminium pan will take longer time to heat. And what is the reason? Now, because more thermal energy is needed to raise the temperature of aluminium. So more thermal energy is required to raise the temperature of aluminium. So then aluminium pan has a higher specific capacity. It's already given there, so there's no need of saying it because it's given to us in the question. Okay, why? Okay, when you just say, okay, to heat the aluminium, because aluminium pan has higher specific heat capacity. So that is why it takes a longer time for it to heat than steel. Okay.